Problem 2.7 in solutions chapter. Henry's law constant for CO2 in water is given as 1.67 into 10 to the power of 8 Pascal, 10 to the power of 8 Pascal at 298 Kelvin. Calculate the quantity of CO2, 500 ml of soda water when packed under 250 atmospheric pressure of CO2 at 298. Right. So let us write the things given here. What they had given, first they had given the values of Henry's constant. KH is equal to 1.67 into 10 to the power of 8 Pascal. Right. And what they had given, the pressure of CO2 at 298 Kelvin, that is 2.58. The pressure of CO2 at 290, that is 2.5 atmospheric pressure, right? And calculate the quantity of CO2 in 500 ml of soda water, 500 ml, right? Here they had given the volume of soda water, 500 ml of soda water. Okay, let us apply Henry's law here. What is Henry's law? The pressure of partial pressure of CO2 is equal to Henry's constant into mole fraction of CO2. This is Henry's law, right? So here, the partial pressure of CO2 has been given, the Henry's constant has been given. So what we have to find out? We have to find out the mole fraction. So it can be written as the mole fraction of CO2, that is equal to partial pressure of CO2 divided by Henry's constant. So that can be substituted as, here before substitution you have to understand here the Henry's constant is given in Pascal and the partial pressure is given in atmosphere. So we have to convert this atmosphere into Pascal, right? So just note it down. 1 atmosphere, that is equal to 101325 Pascal. So this can be written as, that is 1.01 into 10 to the power of 5 Pascal. Right. So 1 atmosphere is equal to 1.01 10 to the power of 5 Pascal. So then 2.5 atmosphere means, let me write it here. That is a mole fraction of CO2, that is equal to partial pressure of CO2 2.5 into 1.01 into 10 to the power of 5 Pascal, converting the atmospheric pressure into Pascal, so that we are multiplying by 1.01 into 10 to the power of 5 divided by, what is Henry's constant? 1.67 into 10 to the power of 8 Pascal, right? So Pascal get cancelled. So 2.5 into 1.01. So that can be written as 2.525 into 10 to the power of 5. If you bring this 10 to the power 8 into numerator, it will become 10 to the power of minus 8 divided by 1.67. So we can write the value is 2.525 divided by 1.67, that is 1.512 into 10 to the power of 5 minus 8. So that can be written as 1.512 into 10 to the power of minus 3. That is a mole fraction of CO2. Let us write here X of CO2. The mole fraction of CO2 is 1.512 into 10 to the power of minus 3. The mole fraction is unitless, so there is no unit for it. We find out the mole fraction. Right. But what actually they had given? Quantity of CO2. They asked for quantity of CO2. Right. So what we got here? Number of mole fraction of CO2 we got. So from this we have to go for number of moles. From the number of moles we have to go for mass of CO2. Right. Okay. Let us go for the number of moles of CO2. That is mole fraction of CO2, that is equal to what? Number of moles of CO2 by number of moles of CO2 plus here whatever is the solvent. So number of moles of H2. So this is a mole fraction formula. Here we know the number of moles of CO2 we can find out. Let us find out the number of moles of water. Number of moles of water, what is it? Mass by molar mass. Mass by molar mass. But we got only the volume of water is 500 ml. This is what we got. Right? This is what we got. So from this volume, we have to find out the mass. So let us go for the relation. Volume of water, volume of H2O, what we got? 500 ml. Right? Density of water. Density of H2O, what is it? That is 1 gram per liter. Right. We can use a volume density relationship here. Density is equal to mass by volume. Mass by volume. Right. Now what we got here? We have volume, we have density. So what we have to do? We have to find out mass. So this can be written as mass is equal to density into volume. Right. Density into volume. Right. So that is equal to mass. That is equal to density. What is density here? 1 gram per ml into what is the volume here? 500 ml. ml get cancelled. So that is equal to 500 gram. This is a mass of water here. So molar mass of water we know that is 80. Right? Molar mass of water H2O that is equal to 1 into 2. Atomic mass of hydrogen is 1 into 2 plus oxygen 16, that is equal to 18 gram per mole. Right? So now again we got the mass and molar mass. So the number of moles we can find out, that is the number of moles of H2O that is equal to mass 500 gram by molar mass 18 gram per mole. Right? Gram get cancelled, 500 by 18. That is equal to 27.78 mole. 27.478 mole. Right? We already got the mole fraction of CO2 is, this is the number of moles of H2. Right? We know the mole fraction of CO2. We found out the mole fraction of CO2 is 1.512 into 10 to the power of minus 3. Right? Let us write the formula of mole fraction of CO2. That is mole fraction of CO2 that is equal to number of moles of CO2 by number of moles of CO2 plus number of moles of H2. Right? This is a formula for mole fraction. Actually, here the mole fraction is very less. It is in the order of 10 to the power of minus 3. What is that? The mole fraction of CO2 is very less. Very less. Right? So that the number of moles of CO2 to the denominator part share is negligible, or we can ignore this, So the formula for mole fraction of CO2 will be number of moles of CO2 by number of moles of H2O. Got it? So already we know the number of moles of CO2, mole fraction of CO2 and number of moles of H2. Substitute this in this formula. So we can write the number of moles of CO2, that is equal to mole fraction of CO2 into number of moles of H2O. So that is equal to mole fraction of CO2 is nothing but 1.512 into 10 to the power of minus 3, right? No unit, into number of moles. We found it out. That is 27.78 mole, right? Got it? So the value we are getting is 42.002 into 10 to the power of minus 3 moles. So it can be rounded to 42 into 10 to the power of minus 3 moles. This is a number of moles of CO2. Right, number of moles of CO2 we have found. Okay. Now, here it is 10 to the power of minus 3 moles. Let us convert the moles into millimoles. Moles into millimoles. That is 1 mole, that is equal to 1000 millimole. 1 mole, that is equal to 1000 millimole. Right? So if we convert the moles into millimoles, what we have to do? We have to multiply by 1000. So 42 into 1000 into 10 to the power of minus 3 millimoles. Right? So the 1000 can be written as 10 to the power of 3. So this can be written as 42 into 10 to the power of 3 into 10 to the power of minus 3 millimole. Right? So these two get cancelled. That is equal to 42 millimole. Right? The number of moles of CO2 is 42 millimole. Right. Now what we have to find out? The mass of CO2. Mass of CO2. That is the question here. We have to find out the mass of CO2. Right? What is the formula for number of moles of CO2? The number of moles of CO2 is equal to mass by molar mass. Molar mass of CO2. Right? We know the number of moles of CO2 and we know the molar mass. Substitute this in this equation. That is, so actually the number of mass of CO2, the mass of CO2, that is equal to number of moles of CO2 into molar mass. Molar mass. Right? We had found out the number of moles of CO2, that is equal to here 42 into 10 to the power of minus 3 moles into molar mass. Molar mass of CO2. Here carbon is 12 plus oxygen is 16. 16 into 2. Right? 32 plus 12. It is equal to 44 gram per mole. So 44 gram per mole. Got it? Now mole get cancelled. So this can be written as 42 into 44. That is equal to 1848 into 10 to the power of minus 3 gram, right? So scientifically, if we shift the decimal to the right, it can be shifted to 3 positions like this. So this can be written as 1.848 into 10 to the power of 3 for shifting the decimal into 10 to the power of minus 3 gram. So these two get cancelled. We can write as 1.848 gram. So this is the mass of CO2, right? Mass of CO2. So this is a final answer here.